So today's topic is inter-integrated circuit I2C. It uses two pins, pin SDA and SCLs. SDA stands for serial data line and SCL stands for serial clock line. These two pins are used by the I2C for data transmissions in the bus. The master device transmits the data to the slave device, and the master device can also receive the data from the slave device. Okay. The master is a device that generates the clock for the whole system. System means whole process of the transmissions, and the slave is a device that receives this clock generated by the master. The master also initiate the start and the stop conditions of the whole process of transmissions. The master and slave can receive or transmit. That means there will be four conditions. Four mode of operations. Okay, this one, four mode of operations. Master transmitting, master receiving, slave transmitting, and the slave receiving. The master and the slave follows only one mode of operations at the same time. That means if it is receiving, then it cannot send at the same time. The bus will be busy, so arbitrations will happen and it will cause to error. I will explain about arbitrations little later. So as the bus can be occupied by only one master at one time, the bus contains SDA lines and the SCL lines. Then, as the bus can be occupied by only one master, there may be situations pop up where two or three masters initiate the transmission process. That means transmitting is still not happening. It's only trying to initiate the process of transmission. So two or three devices may try to initiate the process of transmission at the same time. So at this time the arbitrations happens. Arbitrations means checking the levels of the SDA line is whether this SDA line is high, which is necessary for transmissions of the data, or the SCL this start conditions here is in buffer format, whether when buffer format in the sense when the SCL line is high, SDA line is high to low. All this level of the SDA line and SCL line is checked. So the winning master, only one master will win because the bus can be occupied by only one master. So because of that, other will lost because the level of SDA and SCLs and all the start and stop conditions will be not in proper format. It happens because the data sent by the master or the address sent by the master in the bus is not acknowledged. So because of that, the winning master then occupied this bus and do the process of transmissions of data in the bus to their respective slave device, and until this process is complete, the master that lost has to wait so that times comes for the transmissions of their respective data to their slave device. So this one is data frame format. Data frame format in I2C consists of 9 bits. The 9 bit, out of this 9 bit, 8 bit is the data bits, and the 9 bit is the acknowledgement bit. Acknowledgement is pulling the SDA line low to indicate it is ready to receive the data sent by the transmitters, the master. If it doesn't want to receive the data sent by the master, then it can still keep the SDA line high and it is considered because it doesn't want to receive any data. It may be busy with the data bytes sent before or before process, and it is considered negative acknowledge. This one negative acknowledge, or in short terms it is neck. So sometimes it is asked in the exam, what is neck in I2C data transmission. And so that's the process. So MSB is the highest bit of data. It is sent first. So since it is sent first, it is sent in the first clock cycles 1, and then second highest bit will send in the corresponding 2 clock cycles, and all those corresponding bit will be sent in the clock cycles 3, 4, 5, 6. And then this one send 7 here. Then the lowest LSB bits is sent in the 8 clock cycles, because LSB is sent in the 8 clock cycles because it is the lowest bit, and this data bit contain 8 in total, so the lowest bit obviously will send in the 8 clock cycles, right? Because one bit need 1 clock cycle each. And the acknowledgement bit that pulling the SDA line slow in order to indicate the select device is ready to receive the data transmitted by the master will be, all this process will done in the 9 clock cycles. And then address byte format, and in address byte format it's saying the master send 9-bit in details. This 9-bit in details. Out of this 9-bit, only 7-bit, the first 7-bit is address bit of the select device, and the 8-bit is the read-write control bit. The 8-bit read-write control bits. Read means you are receiving data from the select device. That means you are reading, right? When you read a book, you are receiving data from your book. So likewise, when the master read data, it is receiving data from the select device. And when you are writing in the book, you are writing in your exercise book, right? So in this way, the master is also writing on the select device, and it will be copied later on in the memory of that select device by the select device. And the last bit is the acknowledgement bit. Acknowledgement bit is, that pulling the SDA line low in order to indicate that it is acknowledged. Acknowledgement means that the select device is ready to receive the data sent by the master in the bus to it. And as I have told, if it doesn't want to if it doesn't want to receive any data, then it pulls the then it kept the SDA lines high so that it doesn't receive any kind of data, because it is busy with the data handling the data of the before process. This should be all before process. So negative acknowledgement means neck. Yes, sometimes I'll send example. So this MSB address is sent first. It is the highest bit. So it is sent in the first clock cycles, then the second highest bit will be sent in the second clock cycles, and all the corresponding bit of address will be sent in the corresponding clock cycles, and the lowest bit address will be sent in the 7 clock cycles, because the lowest bit is sent in 7 clock cycles because the address bit contain only 7 bit, right? So the lowest bit will be sent in 7 bit because its bit of address takes only 1 clock cycle each. So RW, this bit will be operate in the 8 clock cycles. R means receiving device from data from the slave device or receiving device, and then write means writing or sending or transmitting to the slave device. Acknowledge, as you know, that pulse the SDA line low in order to indicate that this acknowledge means receiving data sent by the transmitter in the burst to the slave device. So this condition will operate in the 9 clock cycle. And so the start condition after set by the master, the start condition is set by the master only, and the master will put the sender's address in the bus in order to choose a particular slave device. After choosing that particular slave device, it will send one or more data byte, and the stop condition will be again set by the master in order to complete data transfer process. Okay. So in this this is a whole process. Here the start condition is there. Start condition is when the SL line is high, SDN line is high to go. This is the start conditions, and this is MSA LSB. This is the address. Address 721. 721. It should be actually when we count by bits, it will be actually those of the address 0 to 6 like that. Okay, and then read write conditions. It is choosing a particular address of a slave device. That means it has already one slave device, right? And then this read write conditions. Whether to read from the or receiving data from the slave device, or write means transmitting data or sending data to the slave device. It will be done in the 8 clock cycles, and acknowledgement means whether the receiving data or the slave device is ready to receive the data it is going to send by the master. If it is acknowledged, means it is ready to receive the data sent by the master, then all this D8 to D7 D8 to D0 is sent along with the acknowledgement bit. And if it does the receiving device or slave device send neg, then this data bit doesn't need to be sent by the master in the bus to the slave device. After receiving the data so sent, then it will send this acknowledgement bit to the master. It will raise a flag. And so this address is done in the 9 clock cycles. This data is sent in the 9 clock cycles. But if you are sending, one or more data bytes, this is only 1 byte. It's saying one or more data byte. So this clock cycles, it is 9 clock cycles here, but this clock cycles can be many clock cycles depending on how many bytes you are sending, because each bit need 1 clock cycles. So the more the byte you send, the more clock cycles you will need here in the data transmission process. So that's it. And clock stretching means clock stretching is the conditions when the SCL line is kept low and not released by the slave device after receiving the data sent to it, because it doesn't want to receive any more data. So that's the conditions. And so the clock need to be kept hold for some time until it releases the clock line. And then if it releases the clock line that is kept low by it, then the master will pull the clock line to high in order to set the condition of start for transmissions. Okay. To set the conditions of start, the clock line need to be pulled by the master to high level because of that. Thank you all for the session.